Got a math question? Mathline has answers. Hey, Mathline.
Hey Mathline, I'm Lexi from middle school in Alabama. Would you show me the prime factorization of 144?
Ooh, did y'all see that? Almost a big stingray moment coming in there. We were at Ripley's Aquarium, and that's Lexi, middle school student in Alabama who was visiting our area, and we found Lexi to be just a lot of fun and very, very expressive. Good job, Lexi. And she asked the question, what is the prime factorization of 144? Now, when we talk about prime factorization, the key word is we want to see a bunch of prime numbers. In fact, that's all we want to see is prime numbers in the final outcome. So what we've done, I find it's very cool in the past, is working with what we call a factor tree. And we'll start with it. I'm going to do the same thing here because it's fairly easy to watch the fruits of your labor here come together. Now, I've got 144. There's different ways we can multiply to get 144. Some of you say, well, you could do 2 times 72. That's true. That doesn't necessarily help you a lot. But let's go for our times table. Some of the ways we remember, when we learn the 12s, 12 times 12, that kicks. Now you say, well, Ernie, those aren't primes. Exactly. They are not. So what we're going to do, we're going to break these down, and we're going to break that one down, and that's going to become 4 times 3. Oh, you might say 6 times 2. It doesn't matter. And let's do the same thing over here. I should have put 6 times 2 just to give some of y'all a good, yeah, he used my choice. And at this point, notice I have primes. Well, I have 2 of them. I have 2 3s right there. Now, my remaining part here is that I need to break down the 4 because 4s are what we call composite numbers. In other words, it's not just 1 times 4 that gets us 4. We have also, as everybody knows, 2 times 2. So we're going to put 2 and 2 there and 2 and 2 here. Now, I want you to notice what I did here. I put a circle around there because I wanted it to be noticed that they're finished. Those are primes, all right? So we're going to circle our primes when we get done. Don't go back and circle the 4s, the 12s, they're not primes, all right? So let's play out with 2. There's 2, there's 2, there's 2. Wow, a lot of 2s. There's a lot of 3s. There are 2 of them there. So how about it? That'll be 2 to the 4th power, because remember, we multiplied all those together to get back into our 144. And also out here, we've got 3 to the 2nd, which will give us the prime factorization. That's what it is. And we use the exponents here to say there are 4 of those 2's that we're going to multiply together. That means 2 to the 4th power, and it's 3 squared, or 3 to the 2nd power. Then we put the results together. Now, you know what? 2 to the 4th is going to give us 16. Just a little note out here. I put a little equals there because we want to check. And we got 16 times 9. We'll make sure we didn't lose anything. And for those of you who aren't sure about 16 times 9, let's do it right off here. 16 times 9, I believe that's 6 times 9. Think about it. 54. Put a 5 up there. I'm getting 144. Checks out. So Lexi, thank you for that question. And I hope you did enjoy your day at Ripley's Aquarium. We certainly enjoyed talking with you and working with you. And there's your check. It does work. And my friends, those are all primes. Now, question I'm going to go back before we lose here. Let's go back to Lexi. Yeah, thank you. If I had used, let's say I'd used 9 and 16 to begin with, probably most of us wouldn't have done that. We would have still gotten to the same thing because 9 would have given us what? 3 to the 2nd and 2 to the 4th would give us 16. We would eventually break it down. That's the beauty of prime factorization. It's got to work out. It's got to come out there to the final drag. So again, Lexi, thank you for the question. And folks, thank you.